So just as a review, maybe what might help you is, and you're going to need to know this, is that when you have equal to bars, okay, that is going to be a solid line. When you do not have equal to bars, that's going to be a dotted or a dash line. Okay, and this was in your notes from advisory last week. Okay, when you have greater than or greater than and equal to, you're going to shade above. And when you have less than or equal to, you would shade below. Okay? So that's a little review of what all was talked about last week. Okay. So, this is in slope-intercept form, so it's really easy. There's not much of a trick to it. There is no equal to bar, so this is going to be a dotted line. So because it's going to be a dotted line, B is out and D is out because it's going to be a dotted line. Okay? Less than, you are going to shade below. So we could write this dotted, shade below. That means shade below the line. Okay, so these two are dotted, A and D, and which one is shaded below the line? Or C, yeah. So C is the correct answer. Keep in mind, folks, the other part you need to know that we discussed in advisory is, y'all, the shaded area is where your solutions lie. Okay, with an inequality, all the ordered pairs in the shaded region make this inequality true. Here's my question. Are ordered pairs along the dotted line part of the solution? Are the ordered pairs on the dotted line a part of the solution? Yes or no? Okay, thank you for answering yes, but it's wrong. Because, y'all notice there's no equal to bar. Y'all, the equal to bar, which is a solid line, means that if a point falls on the line, it is a solution because there's an equal to bar. Okay, so glad I asked the question. And they'll test you on that. They'll grab a point. They'll grab some point off the dotted line and ask you if that's a solution. It's not. It's got to be on a solid line to be a solution. Okay? All right. Let's go to the next one. Okay, folks, we tend not to like standard form. Okay? That's why I have it on here. So the problem with standard form is that if you were to solve for y here, something's going to happen. So we're going to solve for y so I can show you. The first step to solve for y is to subtract 4x on each side. And I strongly recommend you all do this with me. Okay, so now I have negative 2y is less than or equal to negative 4x plus 12. Question on my first step to solve for y. Okay, what is my next step to solve for y? Yeah, so I'm going to divide every term by negative 2. And this is what students forget. With inequalities, what happens when I divide both sides by a negative number? It's called the golden rule. What flips? The inequality symbol switches direction. You will be tested on that. The inequality symbol is no longer less than. It is now greater than. Okay, because you divided both sides by a negative number. So that's the problem with standard form. Now, some of y'all are good enough, you can just look at it. Wait a minute, the y is negative. I would end up dividing by a negative number. So I know my inequality symbol is going to switch. If you're good at doing that, fine. But notice mathematically, it's that second step that causes that inequality symbol to flip. Okay? So we have 2x minus 6. Okay? So now, we have a greater than or equal to, so do I have a solid or dotted line? Solid. So A is out and C is out. And the inequality symbol has flipped. Again, I can do that right there. That's the reason why it's flipped, because the y is negative. So we're now greater than. So is it B or D? It is D, shaded above. Any questions on that? Did anybody in here catch that the inequality symbol was going to flip? Did anybody in here catch that the inequality symbol was going to flip? Okay, then that means I need to, you did? So maybe I need to put some more on some warm-ups? Okay. All right. This one is from yesterday's advisory. This is a system. Notice it says which two equations are represented in the graph. It's a system, and the solution is where they intersect. You had that in class yesterday. Okay? So now we need to figure out which system works for this. Well, the easiest thing, like me, y'all, the way I would do this is I would check the slopes real quick. I just check my slopes. So I'm going to pick two good points here on this line. And I'm going to rise and run. So I'm going to rise 3 and run 1. So my slope here is 3. And notice my y-intercept. What's my y-intercept here? 2. So my y-intercept is 2. So quickly, I'm going to see if I can knock some stuff off here. Okay, here's y-intercept 3. I'm sorry, slope 3, y-intercept 2. Let me see if that shows up anywhere else. Y'all, it doesn't show up anywhere else. Here's a negative slope. This is a positive slope. So just by checking the slope and the y-intercept of one equation, I've narrowed it down to the only answer. Now, I'm going to check the other one, though. Let's see what the slope is of the other one. Rise 1 and run 1. So we've got a slope of 1. And then y-intercept is 4. So that matches. So the answer was C. And by the way, the solution to this system is where it intersects, which is the ordered pair 1, 5. Just to further extend what we did. Did anybody get that? Okay. Okay, this little fella here, folks, I keep bringing them back up, and I feel like for average rate of change, you guys do fine if you got a table. You guys do fine if you've got ordered pairs. You guys probably do okay if you got a graph, but it's when you get this equation that most of y'all just leave it blank. And you're like, oh, I'll just see what she does. I'll just see what she does. First of all, what is really average rate of change? Slope. It is the slope. So y'all, we have to find the slope. You can't find the slope of an exponential by looking at it. There is no slope. The reason why is because the slope is different everywhere. So we've got to get a set of ordered pairs. How do we get a set of ordered pairs? Well, if they give us the x, what do I do to get the y? They give us the x, what do I do to get the y? Cover it up. No. Divide. No. X is also the input. How do I get the output? See, I can tell y'all left this blank. Y'all, you got to plug it in. Y'all, you got to plug your x's in to get your y, and that gives you the ordered pairs. When you got the ordered pairs, you do. So y'all, I can keep doing this, but at some point, you're going to have to commit this to memory. This will be on your benchmark. I can promise you. And I can promise you it's going to be on your EOC. I can promise you. So, I mean, somehow y'all going to have to, when they give you a value for X, plug it in. Plug it in. Okay? All right, so here we go. So the first thing I'm going to find is f of 3 because x is 3. Okay, so what does that sound like? Well, 3 and in parentheses 2 raised to the blank. Right there's the x. That's where we're going to plug it in. So 3 parentheses 2, and y'all, where the x is where I'm going to plug that 3 in. Okay? You can put this in the calculator exactly the way you see it. I'll say again, I strongly recommend you guys get your calculators in your hand and do this. 3 parentheses 2, close the parenthesis. How do I get a power, y'all? Caret key, and then 3. Okay, so that gives me a 24. Okay, well, y'all, what I just made was an ordered pair. The x part is 3. That was the input. The output is the y, 24. I just made an ordered pair. I need one more. X is 5. So I'm going to find f of 5. So it's 3 parentheses 2, and where the x is, I'm plugging a 5 in. Okay, so I'm going to go to my calculator. 3 parentheses 2, close the parenthesis, caret key 5, and I get 96. So I just created an ordered pair for this function. It's the ordered pair 5, comma, 96. And now that we have ordered pairs, we can do. So I'm going to do the BBBS for slope. Down, up, and now we just simplify. Let's see, 6 minus 4 would be 2. I think that's negative 72. This would be negative 2, and that would be 36, I believe. A positive 36 is the average rate of change. Telling ya. It's going to be on your standardized test. It's going to be. We good? Yeah. Okay. All right. So, good stuff here, y'all. Maybe look over it before your test. All right. So you're going to need your notebooks out. Okay. 3 pages. And we want to keep with the same format. So we're going to put an L on the left. What's that stand for?
Linear.
Okay. We're going to put an E in the middle. What's that stand for? Y'all go. And we're going to put a Q on the right. Quadratic. We're focusing on quadratic. Okay. Okay, so what I've got for us today could possibly take up more than this page. So if you follow me, I'm looking because I think I got rid of my notes. I did. Just tossed them right in the garbage. Okay. So basically, if we need overflow, we're just going to open up that middle page where we've got a blank one, but we're going to see how we do here. So what we're getting ready to do is now solve a quadratic. We're going to solve a quadratic equation. And you probably like, what have we been doing so far? Y'all, we haven't solved an equation so far because there's been no equal sign. Okay? If you flip back and you look at every one of these problems, there is no equal sign, y'all. This is nothing but an expression. Same thing here. There's no equal sign. We have not solved anything for the last week. We have converted from standard form to factored form. That's all we've done. Now we get ready to put an equal sign in it, and we're going to solve quadratic equations, just like we would solve a linear equation, okay? We're going to solve quadratic equations. So, right up here at the top, we're going to write solving quadratic equations, and I'm just going to use EQNS, okay, by factoring. So that's how factoring is going to come back into this. Okay, that's what this page is going to be. For Math 1, for the most part, this is the only method you learn for solving a quadratic. I told you that next year, Math 2 is all quadratics, everything about it. And you're going to learn more than this method to solve a quadratic. There's 4 total methods. So, and it's a big deal. Quadratics is it's got a lot going on. So it takes a whole year to do. So in Math 2, you're going to learn all about quadratics. In Math 1, we just start by teaching you one method to solve by factoring, okay? So the first thing you need are the steps to solve. So what I did is I gave myself a little bit of room. Let's see, 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. We can just come right here. Okay? This is where my steps are going to go. This is where my steps are going to go. Okay? You already have the steps somewhere. Where'd I do it? Right there. Right next to the flag. Solving quadratic equations. I just want them in your notes in case you're at home, you have them. And it does give us something to talk about here. So step number 1, okay, you are actually going to get all your terms on one side equal to 0. So get all terms on one side equal to 0. In other words, if they're all on one side, then the other side has to be equal to 0. And y'all, that's nothing but adding and subtracting terms to move them across an equal sign. That's all that is. And you've done that before. Okay? Second step that you've done before. You're then going to factor. So you're going to factor. Third step, and this is where the new part comes. You are going to set each factor equal to 0 and solve it. You're going to set each factor equal to 0 and solve it. Just so you know, you will get either 1 or 2 solutions. If you remember, we discussed your x-intercepts, and I kept saying, how many x-intercepts can you have with a quadratic? And y'all would say 2. Well, you can have 2 solutions. And you're going to see the connection here soon. Okay? All right, so y'all, if you follow these steps, you'll solve a quadratic equation. Okay? So the next thing I've done to help you out is I have kind of separated all 3 factoring ideas that we've done. So if you look, we started off by just factoring by the greatest common factor method, where you put your GCF on the outside and you fill in the parentheses. We started there. Okay, the one you guys tend to be pretty good at, with the exception of the X part, is trinomial. We do this and we do this to get our factors. And then this guy is called a difference of squares, and that's the one that's so easy you can just eyeball it and pop it. Oh, I made a mistake. Oh my goodness. We can't have that there. So that's the one that you just eyeball and pop in the perfect square factor. Wow. That is not good. What mistake did I make, by the way? Right, it's not 2 positives. One of these has to be a minus sign. One of those has to be a minus sign. I'm going to have to get white out and get rid of that plus. Okay, so Those three are the factoring types we're going to use to solve a quadratic. Each one here. I'm going to try to give you an example of each one. So let's start off way up here, y'all, trying to save a lot of room. See, now, y'all, they don't say factor. They're going to say solve. So, because we're solving an equation. 2x squared equals 8x. 2x squared equals 8x. Okay, so first step says get all the terms on one side of the equation. Are all the terms on one side of the equation? No. They're not. So y'all, I either need this guy to come over here or this guy to come over here. What's going to be the best thing to do? Yeah, the reason why, y'all, is if you move this guy the other way, you're making him negative. And remember, we don't like that negative stuff on the x squared. We don't want that. So, y'all, I'm going to move the 8x to the left, but I've got to do it mathematically. So how do I do it? Y'all have done it before. I am going to subtract it. So, y'all, I am going to subtract 8x on both sides. Okay, y'all. 8x minus 8x, notice, y'all, I've now got a 0 on one side of the equal sign. Please be careful that you don't think you can combine these. You cannot combine these. Why not? One's got a square and one doesn't. So, y'all, we're just going to write it in the correct order that makes it look good. So, I'm going to write my squared term first, 2x squared minus 8x. So I completed step number 1. Get all your terms on one side. Okay, what's step number 2 tell you to do?
Factoring.
Okay. Here's the 3 ways we've done it. Take a look and tell me what you think we're doing. Got 3 ways. It can't be a trinomial. How many terms does a trinomial have?
3.
Tri means 3. Look, there's only 2. So it can't be a trinomial. You're down to the GCF or difference of squares. Is 8 a perfect square?
Yes.
It is not. Is 2 a perfect square? It is not. Y'all, we just wrote our perfect squares. 1, 4, 9, 16, 25, 36, 40. Okay, so 8 is not a perfect square. 2 is not a perfect square. X to the first power is not a perfect square. So y'all notice we've already narrowed it down. What method are we using? Hey, y'all, there's some giggling going on and you got to stop. This is important. And while you're giggling, you're not listening to me. Okay, so y'all, there's no factoring method left but greatest common factor. That's it. So what's the greatest common factor? It's 2x. So I'm going to leave a little space. I'm going to pull the 2x out, and I'm going to set up a parenthesis. And don't forget it's equal to 0. That's not a big deal, but if we're going to do it right, let's do it right. Okay, I'm going to divide everything by my GCF. So you guys fill in the blank before I do. Okay, what do I get? Okay, almost. The 2's cancel. I get x minus 4. Okay? So it's now factored. I can't factor again, y'all. That's an x to the first power. I'm done. I'm done. Okay, so now what does step number 3 say? Set each factor equal to 0. Don't forget, y'all, this little guy out here in front is a factor. So we are going to set 2x equal to 0. That's one of my factors. We are going to set x minus 4 equal to 0. And notice I dropped my parenthesis because it's just going to confuse you. One of my factors is x minus 4. I set it equal to 0. One of my factors is 2x. I set it equal to 0. Y'all, we're back to one-step equation here. How do I solve for x here? It's a one-step equation. Divide both sides by 2. Okay, so what's one of my answers?
0.
One of my answers is 0. And that is an answer, folks. That is an answer. Okay, one step here. What do I do? Add 4 to both sides. So I get x equals 4. How many solutions did I get?
2.
Yeah. How many x-intercepts have I been finding on these quadratic graphs? 2.
2.
Okay, so I want to show you something. So we're going to solve x squared minus 14x equals negative 49. What's step number 1? Step number 1, that's under your steps. Yeah, we've got to get everything on one side. Y'all, the x squared's positive. Let's leave it exactly where it's at. We don't want the x squared to be negative, so let's get that 49 to the other side. So y'all, we're going to add 49. Notice it is now set equal to 0, which is what I needed to happen. I cannot combine any of this, so we're just going to write it. X squared minus 14x plus 49. What's step number 3 tell us to do? Factor it. Boom, boom, boom. There's the 3 things we've done. Which one is it? Trinomials. How many terms do I have?
3.
Trinomials. Now, y'all, you always want to try to pull out a greatest common factor here. So take a quick look. Is there a greatest common factor here? There's no greatest common factor. So we're doing trinomials. So here we go. We're going to set up our 2 by 2 box. We're going to set up our x. And here we go. First term, first box. Last term, last box. Throw your x's in there. Multiply together. We have a 49 on top. What goes in the bottom of the x? Negative 14. And now we need the magic numbers, and those are the things you guys don't like very much, finding the magic numbers. So I'll pause a minute, let you think through the magic numbers. What's my magic numbers? -7 and -7 are my magic numbers. So let's pop those in there. Okay. Right, finding greatest common factors here. I'll pause a minute, let you do it. Okay, you should have gotten x and 7 and x and 7. And I want to say this. Folks, there is a reason why I do not want you to pull the negative out if it only shows up one time. The reason why is because when it gets to the other type, where there's only one negative getting pulled out, I'm afraid you're going to pull the wrong one out. So I always tell you, do not pull the negatives out unless they show up in both terms. Okay, so I'm going to set up my 2 parentheses. I've got an x and a 7 and an x and a 7, and I always look at my magic numbers to see what the signs are. They are both negative. And don't forget, this was an equation set equal to 0. So I have now factored. What is my last step? What is the last? Set each factor equal to 0 and solve it. So one of my factors is x minus 7. I set that equal to 0. And you guys are probably going, wait a minute. It's the same thing. It is. My other factor is x minus 7, and I'm going to set it equal to 0. One step to solve these. We're going to add 7 to both sides. Y'all, I'm going to skip that step. Basically, we're going to get an answer of 7. Y'all, that is one answer. It is one answer. 7. It's called a double root. It's called a double root. I want to show you what that looks like in a graph. Okay. Let's see what that looks like. X squared minus 64. Notice our answers are the x-intercepts, y'all. You're going to need to know that. Our answers are the x-intercepts. Those are the answers. Negative 8 and positive 8. The solutions to a quadratic are the x-intercepts. They're also called zeros. And y'all, you'll be tested on that. You're going to see something that just says find the zeros. And you're going to have to know, what do they want from me? Oh, wait a minute. Find the zeros means I'm solving this. Okay? All right. Okay. So we just solved that one, and unfortunately I didn't hit the undo the pause button, so they missed that one in the video. All right, but let's keep going. Okay, so hopefully we get y'all all have a little room right here. I think we're on problem number 4. Solve 2x squared equals x plus 15. Step number 1. Get all terms on one side. Folks, I know we've got 2 terms to move here, but we don't have to. Let's just do it all at one shot. How would I move the x? Subtract it. How would I move the 15? Yeah, just do it on one line. So check it out. I'm going to subtract x. I'm going to subtract x. I'm going to subtract 15. I'm going to subtract 15. Do you see? And some of y'all are going to skip that all together. You already know what's going to happen, and you're just going to write it. Okay, but notice, see, now everything's gone, and now I have 0. And now we got to piece this thing together. So we want to put the squared term first. So that's 2x squared. I want to put my linear term next, which is minus x. And then my constant term, which is minus 15. Do I have a greatest common factor here? I don't. So which 3? Trinomial. Here we go. Okay, I'm going to pause and let you guys try without me. All right, so folks, y'all, I purposely did this. You have got to get in the habit of realizing you are multiplying these together. And y'all, over here, when you have the easy ones, you don't have to think about that. See, there's an understood one there. Y'all, you got to remember these 2 things have to be multiplied together. So that should be a negative 30. What goes on the bottom? Negative 1, because that middle term is a negative 1. Okay, now I'm going to pause again. Here we go. What were my magic numbers? Negative 6 and positive 5 were the magic numbers. So I'm going to pop them in. Okay, and again, if you actually went ahead of me, it doesn't matter if yours went in different boxes. It doesn't matter. If yours went in different boxes, then what I get on top, you're going to get on the side, and what I get on the side, you're going to get on the top. Okay, now, let's try greatest common factors, folks. Let's try greatest common factors. Across the top. Across the top, Anthony. GCF across the top.
Like going this way?
Right here. Boom.
2x.
2x. Okay. Straight across the bottom, Logan. GCF. It is 5. Okay. Straight down the first column, Riley. It's just an X, that's right. Y'all, with a 2 and a 5, there's no, it's 1 is the common factor. Okay? And straight down the last column, Michael. Okay, does 6 go, and y'all, everybody likes to just pick the smaller number, so I see why Michael did it, but does 6 go into 15 evenly? It is not 6. It is a 3, and 2 doesn't go into 15. Y'all, it's a 3, and you've got to pull the minus sign out because the negative showed up twice. Okay? Okay, we're ready. 2 parentheses. Remember, it's equal to 0. The first parenthesis has a 2x and a 5. The next parenthesis has x minus 3. When I look at my magic numbers, the signs are different. Signs have to be different. Y'all, that's why I'm training you just to pull the minus out when it shows up twice. Because, see, it makes it real easy now because we know this other one is a plus. What's my last step to this? Set each factor equal to 0. So we've got 2x plus 5 equals 0. We've got x minus 3 equals 0. Let's do the easy one. This is a one step. How do I solve the one step? Add 3, so my answer is going to be a positive 3. I'm just going to skip that step. Now, y'all, I'm not going to skip this one because this is 2 steps. How do I solve this one? It's 2 steps. Not add 5. We're going to subtract 5 from both sides. So I get 2x equals negative 5. And what's my last step? Divide both sides by 2. X equals negative 5/2. And again, y'all, notice when you've got a number out here in front, chances are you're going to get a fraction, and it's okay. These are your 2 solutions. Okay? Okay, we are going to do one more, and then I'm going to call it a day because you guys are glazed over. So I'm going to call it a day. And tomorrow is when the big stuff gets started because you're going to have to be able to do this by yourself. I'm going to guide you a little tomorrow with some whiteboards, but after that, you're going to have to do it by yourself. I need you to stick with me for one more. So I'm out of room. So y'all, I'm just going to do this. I am going to flip that middle page over to give me a free page. You ready? I just flipped the middle page backwards is all I did. We're still factoring and solve. Well, step number 1. All terms on the same side. Which way we need to go here? What should we be moving? Yeah, y'all, the squared term's negative. I don't even want that anyway. So let's move it, and that fixes the problem. So how do I move it? I'm going to add it. So I'm going to add 2x squared to both sides. Notice exactly what I wanted. It's equal to 0, and now I need to put these pieces together. I want the 2x squared to go first. Then I've got a positive 14x. Then I've got a positive 24. Okay, there's a reason why I made you guys go through all this, because this one's a little different. If you look up under your factoring methods, what does it say at the very top? Look for greatest common factor first. Do I have a greatest common factor in this?
Yes.
I do. So y'all got to do that first. Okay? So, we're going to pull a 2 out. We're going to set up a parenthesis. You guys can probably do this in your head. If I divide by 2, and divide by 2, what goes here? I mean, I can write it. I don't mind writing it. Divide by 2, divide by 2, divide by 2. What's the first term? X squared. Okay? Middle term. Plus 7x. Last term. Plus 12. Don't forget your signs. So, now we got a trinomial in the parentheses. So I'm going to factor it. Remember, 2 is part of your answer. If you remember that, 2 is part of your answer. So I have already brought it down. Okay, so I'm going to pause a minute. We'll let you guys mess around with this. Did you guys figure out the magic numbers? 3 and 4 are the magic numbers. Okay, we got to get greatest common factors across and down. All right, let's do some new folk. Across this first row, Braden, what's your GCF?
X.
That's it. Okay. Across this second row, Ayana, what's your GCF? Say again. Not X, because it's not in both. Who wants to throw Ayana a lifeline? What is it? It's a 4. That's exactly right. And y'all, it is the smallest number. I just quickly checked. Does it go into 12 evenly? It does. So it's 4. Okay? Okay. Down the first column, Caden, GCF. It's an X. There's an X in both of them. Okay? And down the last column, Emma, it's a 3. So let's pop them bad boys in. Let's take a look. Signs are positive. Now, I want to address some people that are sharp, that are paying attention. Y'all, you may have noticed that when this is, like, there's nothing here, like it's just a 1, that these end up coming here. That's what happened. I'm just going to say. When this has a 1 on it, y'all, we call these easy trinomials. The reason why we call it easy trinomials is because pretty much those magic numbers just go right there. It's just, it's easier to teach one method. If there's a number here like 2, 3, 4, that's called a hard trinomial, and you gotta go to the box. I just teach them all together. But if you get good at this, you're gonna realize that if this is just a 1, that these are actually the answers in there. They're the answers in there. Okay, so here we go. Now, another little aha moment here. What does it say to do for my last step? Okay, this is important, y'all. Y'all, 2 is a factor. 2 is a factor. 2 gets set equal to 0. We're going to talk about it in a minute. 2 is a factor. 2 gets set equal to 0. Remember, we pulled that out to begin with. Okay? X plus 4 is a factor. We're going to set that equal to 0. X plus 3 is a factor. We're going to set that equal to 0. Now, we got to solve. Okay, now I want y'all to take a good look at this. And I'm going to take you back to the first problem we did today. I want you to look at this factor that I set equal to 0 and that factor that I set equal to 0. There's no x. Y'all, this is just nothing but an untrue root. It's not true. But y'all look here. Y'all, that's got an x. We can solve it. You just cross through that one. You do not cross through that one. That was the first problem we did today. You cross through that. There's nothing to solve. It's just untrue. Okay? It's called an extraneous root. Okay? You just cross through it. Okay. So what's my answer to this one? We can skip the step. X equals negative 4. Because we're going to subtract 4 on both sides. What's my answer to this? X equals negative 3. Again, we got 2 answers. It's a quadratic. Y'all, that's another reason why this isn't going to work. Power of 2 can have at most 2 answers. So if I made an answer here, I would have 3 answers. You can't have 3 answers with an x squared. Okay? All right, folks, you probably got a bit of time left. We're going to stop here. So